Because Miss Leslie's going to go, we'll move across. Okay. So at this point in time, what we do is we would go around to the groups and so, just ask. Okay, give us some examples. What do you think's going to happen?
It's either they're going to roll away, separate, or it depends on the strength of your wind, how hard you're blowing through the velocity.
Okay. Perfect example. This one, that's a great question you lead into. Why would it make a difference? Why is it going to make a difference in velocity?
Well, it could blow them over.
Okay.
The amount of energy used.
It's just like the wind against a tree. If it's barely blowing, nothing's going to happen. But if there's a huge wind, you can lose everything.
Okay. Good. Excellent. What do you guys think's going to happen?
We've got various scenarios.
Okay.
At the beginning with the separation, the converging, the displacement of the straws and falling over, and nothing.
Okay. Good. What do you guys have?
We talked about the straws, the cans blowing over. OT said the cans would come together.
Okay.
So
Notice how she threw me on.
It said some straws will blow away, cans will move towards each other, cans will move apart.
Okay.
We did have a definite.
What's that?
The straws will not be usable.
Will not be useful.
I took it through. So
That's
I
exactly right. We'll use them at the Whalen House, so we're.
Oh, I
Okay. All right. Now, the next step in this would be, honestly, is I would say, okay, now you guys had all these scenarios in your group. I'll say, now come up with one scenario per group. The reason we're doing that is because we want a little argumentation right here. You want that? You guys all kind of gave your ideas. Now you're going to present amongst your group, and you're going to come up with hopefully. You guys are through argumentation, maybe not argumentative writing. I don't know that you're going to write it down in this situation, but you're going to support what your decision is. Okay? And whoever gives the best argument or whatever that everybody goes along with, then that will be your group, what we're going to do. Okay? So, now that's what we would do in a normal setting, and it would take a little while. Okay, now then what I would do is we're going to actually do the demonstration. Okay? And at the end of the demonstration, I'm not going to go, okay, this is why this happened. No. Then it's going to be your time to discuss amongst yourself why it happened. You guys will come out with possible scenarios, and then we'll go into the research part of it and everything like that. But here we go, and it might not work. Who knows? All right, here we go. Good. That actually came together. It's what should have happened if I had better straws.
What's your name?
I was nervous.
Yeah. I'll do it again. Good.
That one's spinning.
Okay, so in your groups, why did that happen? In your groups. I think it's because of my straw. I won't tell you why it happened, but I'll tell you they should be coming together.
Do it again. So say why?
Yes, right now, you guys in your group.
I want your book back.
Huh? Okay. Sure.
So what if you did it without the straws?
Well, they're going to be too much friction for the cans and everything. They're probably not going to move. What this is trying to do is this is trying to, basically reduce friction so there's no friction. It'd be perfect if they could gravitate, if we could sit there and get them to float, but...
You can't do that?
Hang up on strings.
Okay, why do you guys think? What did you think? Come up with.
We think the straws, we think, right, that the air's flowing through and it's making that rotate and pulling.
Makes the can rotate.
And pulling it towards the other
Okay.
one.
All right.
Mr. Emlon,
I don't know if I said that right.
When you're blowing through the two cans, you're lowering the air pressure,
because moving air has lower air pressure, so the air pressure on the outside of the can's pushing it.
Okay,
Exact same thing.
is that what you guys think?
No, it's Bernoulli's principle.
I don't think so.
He's got a picture showing that.
Okay, so now, at this point, what I would do, at this point is I would say, okay, you guys all have your theory of what happened, and hopefully you would have, great, in a perfect world, you have iPads or computers available for every student. If you didn't, maybe this is something you did towards the end of the class period, and you said, okay, tonight you're going to go home and research why this happened. Okay? So now, you pulled in argumentation, you pulled in collaboration, okay? And now you're going to pull in the research model part of it and have them go home and research it. Okay? So then the next day, of course, we're going to come back and what we're going to do, go around the room. I'm going to say, okay, what did you find out? I'm going to let everybody who feels like talking tell me what they found out. Okay? Now, through all that, then at that point, I'm going to say, okay, meet in your groups, and you guys come up to your decision. I want one group decision from each of you. Again, we're going back through. We're taking that research. We're making these kids talk about it. Maybe this student got half of it, and this student got the other half of it, right? And they're, together, talk together, they come up with a group. Again, collaboration. Okay? So we'll go through that process. And then at the end, we'll have each group maybe present. We'll have a person, from each group get up and present why they think it happened and try to explain it. Okay? So now we've even brought the presentation part of it, getting people up and speaking and all. So something that is really, and she is exactly right, all this is the introductory to Bernoulli's principle. Bernoulli's principle is simply what makes airplanes fly. Okay? And what Mr. O'Malley explained is exactly right. Moving air has less air pressure because it's moving air particles, so therefore the other, air pressure on the other side creates lift. Okay, creates lift. When I was in college, I had a great methods teacher. His name was Alan Harker, and he was awesome. And he made a statement one day in class, and it was kind of funny, but I remember it to this day, and it makes you think about this kind of stuff right here. He said, "Nothing in science sucks." And we're all like, what? Nothing in science sucks. And so we're talking about it and everything, and I was like, no. A vacuum cleaner? What's a vacuum cleaner do? It does the same thing as Bernoulli's principle. It moves air inside of the vacuum, creating less air pressure, so therefore the air pressure outside pushes things up into the vacuum cleaner.
It doesn't suck.
It does. It pushes, exactly right. I promise you. Okay? So, anyways, and it's just, and because those things right there, that is one thing we talked about, we discussed, and I always remember. So, now, basing it on the Common Cores, okay? Basing on Common Cores. Students who take this much time on a demonstration like this, which all we're doing is really, we're introducing one principle, okay? But now, we've made them, discuss it. We have not gave them the answer. They still don't know the answer until the last point, until after they've all given their presentations, and then I'm going to say, okay, this is why it happened. And then I'm going to explain Bernoulli's principle. And then at that point, what I'm probably going to do is I'm going to say, okay, maybe the next assignment on this is, I don't want them to sit there and answer questions on Bernoulli's principle. What I want them to do is I want them to go make something that exhibits it. Whether it's a paper airplane, whether it is, some other type of apparatus. Maybe it's some type of vacuum cleaner or something like that. But something that exhibits Bernoulli's principle. Then maybe the next step is, okay, I need you to come, I want you to go home and research, and tomorrow I'm going to give me 5 things in life that use Bernoulli's principle to be successful, or whatever. Okay? So, there we go. We've gone through all this, and instead of sitting down and say, okay, here's handouts on Bernoulli's principle, answer these questions, and you should know it. No, that's not teaching. That's not teaching to the way it should be today. A lot of the things, I'm a very simple-minded person. A lot of things Miss Watts set up on stage, I'll be real honest, I sit there going, what? But I do understand this. If it's kind of like the old adage as far as, you give a person a fish and you'll feed them for a day, you teach them how to fish, you feed them for a lifetime. It's the same thing. If we teach our kids how to take information and apply it in everyday life, they're going to be successful. If we just feed them full of information, they're going to regurgitate it on a test, and then when they get out in life, they're not going to be able to to use it. And that's what we've got to do. We've got to get our kids to the point where they can use it, and that's going to make them be more successful in life. Pythagorean's theorem. We throw that at them, we make them, copy down the definition, we make them work problems on it and everything, but how many of them have used it to build a deck? Or, to build a house, or, little, whatever. They need to learn how to apply that, and we use it all the time. So, Common Core is all we're doing is we are changing the way we think, not what we teach. It's the same stuff. We're still teaching Bernoulli's principle. Here in a minute, Miss Leslie's going to get up and show you guys something that she did in her classroom, which was incredible. I just happened to be in there observing that day, and it's awesome because she ties so much stuff together and makes them think. And instead of just reading the story and answer questions, she breaks it down, and it's awesome. But again, it's not, like Miss Watt did say on stage. She said, just because you've always done something that way doesn't make it right. I can't stand someone who says, well, we've always done it here that way. Well, that don't mean it's right. I can't stand that. If you're not always looking for a way to improve, you need to get out of the business, no matter what business you're in. And the dang sure is if it's for kids, okay? So, like I said, this is simple. I have 2 books full of things like this, and it's nothing fancy. Look, my preparation was to get 2 cans. I didn't even drink the 2 cans because I don't like Diet or Zero at all, and some straws, and read 1 paper, and that was it. That was my preparation time. That's all I did. So you don't have to go out and do some big, huge thing where it takes you a week to prepare. All you got to do is throw it out there at them and not give them the answer. And help them, you might lead them in that direction, but make them go find it. Make them apply it. And then it becomes authentic. Okay? And that's what all this stuff's all about. But thank you for your time. I have copies of this little demonstration, plus I have those books in my office. I know one person's already going to take them and copy them, but you're more than welcome if you want to get with me. I'd be more than happy to let you guys have them and copy. Yes?
The name of them again?
There's not a name of them. It's all compiled from experiments. Huh? Oh, this deal, Brunelli's principle?
The books, the 2 books.
There are no names. They are compiled from a bunch of teachers and a bunch of science teachers at OSU and stuff. They did a study, and when they did, they put all these together, and I got a copy of them.
He originally called them discrepant events.
Discrepant events. Yes, I'm sorry, discrepant events.
I want it after each show.
Okay, excellent. And like I said, I have copies of this. You can grab them afterwards. Be fine. Now, I guess at this time, I'll turn it over to Miss Leslie and let her go.